Can you see my screen?
Yes, sir.
Okay, so I welcome you to the sixth interaction session on atomic and molecular physics. Today we will discuss a few problems which will be based on week 6 lectures. Myself, Vivekananda Naik, I am a PhD research scholar in the Department of Energy Science and Engineering, IIT Delhi. So let's start our session. So the first question is the quantum mechanical operator for the momentum of a particle moving in one direction is given by notations have their usual meanings. Option A is minus ih cross d by dx. Option B is ih cross d by dx. Option C is minus ih cross del square. And option D is minus ih cross del. So these are the four options. And we need to choose the correct option which represents the momentum operator, the mechanical operator for the momentum of the particle moving in one direction. So these are the four options. I'll give you some times to try it and solve it. Then we will discuss. So can you tell me which one of the uh, four options will be the correct option?
Option A, sir, minus I h cross d by dx.
Yes, absolutely correct. So can you tell me why option A is correct? Any other options are not correct? I mean, why the operator is minus ih cross d by dx? It can also be ih cross d by dx. Why it is negative of ih cross d by dx?
For three
So if you
dimensional means we will use it
yes,
minus I h del, sir. But the question itself is mentioned only for one direction. Since all are mentioning two options are mentioned for x direction. That and also momentum is minus. That's why minus I h cross d by dx.
sorry, can you speak once again? I couldn't hear you properly. Hello.
Sir, in question they have mentioned in one direction only. Actually, for
Yes.
three-dimensional quantum operator, we equal to I h cross del. So in
No, no,
one direction,
that's okay. No, no, I am saying for three dimension it is minus ih cross del. But how
yes,
you
sir.
can say that it is minus ih cross del? How the operators are derived? It's not like we know this is the value of the operator, but we should know also that how this value gives us the actual momentum of a particle. So basically, if you see in quantum mechanics, all the physical quantities are expressed in terms of operators. Like in classical mechanics, we have the quantities. In quantum mechanics, there are operators. So, and like in classical mechanics, in order to in order to know about the system, we need to know what is the equation of the state or the equation of motion of the system. Similarly, in quantum mechanics, there is a quantity which is used to describe a quantum mechanical system. So can you name that quantity? Yes. So if this is a operator, this operator should be operated on onto something, na, which will give us the actual momentum. So the quantity is called as wave function psi, which
Yes,
is
sir.
wave function. So when you operate the momentum operator, it will give you the value of momentum, and the wave function will remain same. It will not change the wave function. So if you see, um, now the question is in one direction. So can you tell me what is the equation of plane wave in one dimension? Yes, can you tell me? We can represent it as psi in terms of x and t. So can you tell me what will be the plane wave equation? So it will be exponential. There, there will be some proportional, sorry, normalization constant, and it will be exponential ikx minus omega t, is not it? Or in three
Yes, sir.
dimension, it will be, this is one dimension, but in three dimension, if we write, it will be exponential I k vector dot r vector minus omega t. This is in three dimension. So we will now consider the wave equation in one dimension. So the wave equation in one dimension is a exponential I kx minus omega t. And you know this k is which space? This part corresponds to position, and this part corresponds to time. So now if we change the coordinates, then we can replace k to p, that is momentum, and omega to e, that is energy. So how can we convert k to p and omega to e? So you must be knowing p is generally written as h cross k, is not it?
Yes, sir.
So similarly, E is written as h cross omega. So if we multiply h cross and divide it by h cross, then it will be a exponential I by h cross. It will be px minus et. So this is the momentum. So now let's first take the derivative, because since the momentum is with the position part, then if you take derivative, then this p will come out. So if you take derivative, psi del psi by del x, it will be a exponential I by h cross px minus et into I by h cross p, is not it? Then you see this is nothing but psi. So we can write it as I by h cross p psi. Then if you take I by h cross to that side, it will be minus I h cross del psi by del x equals to p psi. So this is the equation. Now I told you, if this is a momentum operator, then it is operated on a wave function, then it will give us the value of momentum and the wave function again, because suppose I am calculating the momentum of a particular state. Now when I want to measure the momentum, then I will operate the operator momentum operator. But when I operate the momentum operator, the wave function, if the state changes, then we can't get the actual value of that operator. Na? So in both the side, the wave function should remain same, and this equation is called as eigenvalue equation, and this value is called as eigenvalue of this operator. So if you compare the equation with if you compare this equation operate p psi is equals to eigenvalue of psi, or so we can write eigenvalue equation. Generally, if a cap is operated on a wave function psi, then it will give us. So this is the operator. This is the eigenvalue, and this is wave function. So have you heard of Hermitian operator?
Yes,
Yes.
sir.
Uh, So basically, if there will be some question, then we'll definitely discuss about that also. But basically, Hermitian operators are those operators for which they have real eigenvalues. So if you compare this eigenvalue equation, now if this operator A is Hermitian, then this small a should be real. So here you see, if you compare the previous equation with this equation, we can clearly say that the momentum operator is minus IH cross del by del x, because when this momentum operator is operated on the wave function side, it gives us the momentum and again that wave function psi. So this momentum is the eigenvalue and this is the momentum operator. Basically, if you see, the Hermitian operators are generally those operators whose complex conjugate is equal to that original operator, then this operator is called a Hermitian operator. So now if you take the adjoint, this is complex conjugate is otherwise called as adjoint. So if you take the adjoint of this operator, then IH cross del by del x adjoint. So my complex conjugate of I will be minus I. So minus IH cross and del by del x conjugate is minus del by del x. So if you multiply, it will be again minus IH cross del by del x because minus 1 is already here. So this will be minus IH cross del by del x. So this operator is again known as a Hermitian operator. So this is the momentum operator in one dimension, and this is, and in three dimension, this is the momentum operator. This is in three dimension, and this is in one dimension. So the option A will be the correct option. So similarly, can you tell me what will be the operator for energy? So I just told you that this is the expression. Let me add another slide first. So my screen is visible to you.
Yes, sir. It's visible.
So I told you the plane wave wave function is given by a exponential I kx minus omega t, which can also be written as a exponential I px minus et. And I told you how we know that minus I h cross del by del x is the momentum operator. So similarly, can you tell me what will be the energy operator? How you can calculate what will be the, how you can basically determine what will be the energy operator for this particular wave, from this particular wave function? So you just tell me in the exponent of the exponential function, like p is in the space part, in energy is in the time part, is not it?
Yes, sir.
So if you take first derivative of psi with respect to t, then E will come outside. You understand?
Yes, sir. Yes.
So just like that, derive and tell me what will be the operator of energy. First, take derivative with respect to t, del psi by del t will be a exponential I px minus et into I e minus I e minus I by h cross here, I by h cross by h cross. So if you see this del psi by del t is minus I e by h cross into psi, is not it? Then I h cross del psi by del t will be e psi. Now you got it. What will be the expression for momentum operator? Sorry, energy operator.
Yes, sir.
Tell me what will be the expression for energy operator?
I cross for one dimension.
I h cross del by del t.
Yes.
So this is the energy operator. So this is the procedure through which you can derive different type of operators. So let's go to the next question. Now the next question says an electron with energy E is incident from left on a potential barrier which is given by Vx equals to 0 for x less than 0 and Vx equals to V0 for x greater than 0 as shown in figure. For E less than V0, what will be the space part of the wave function for x greater than 0 is of the form. So for E less than V0, the space part of the wave function for x greater than 0 will be the option A is e to the power minus alpha x, option B is e to the power minus I alpha x, option C is e to the power I alpha x, and option D is e to the power alpha x. So these are the four options. I will give you some time to try this question, and then after you try, we will discuss how to deal with these types of problems. Basically, this question is purely quantum mechanical. This question belongs to pure quantum mechanics. So why we are solving these questions? Because this week's lectures cover the concepts of quantum mechanics, and then in the next week you will be finding out how the quantum mechanics is applied to derive informations about hydrogen atom and its energy levels and other wave functions all. So please try this question. After some time we will discuss. Yes. Can you tell me what will be the space part of the wave function for x greater than 0? So the question says an electron with energy E is incident from left on a potential barrier which is given by Vx equal to 0 for x less than 0. That is, so you can clearly see this is the potential barrier and the value of the potential is 0 for x less than 0. So here this is 0, V0, and here this is a constant value V0, and the particle is incident from left. That is, this is the particle which is incident, and if you see the energy with which it is incident, this energy is less than V0. So this is the condition also given. This energy is less than V0. Then we need to find out the wave function, and from that we can calculate the space part of the wave function, and also that is for x greater than 0. So in this region, now this is region 1 and this is region 2. So this is the two regions in this question. We need to find the wave function in the region 2. So how we will proceed first? Can you tell me?
No, sir.
So basically, like I just told you in the previous question, that in classical mechanics we always need the equation of motion, and from that equation of motion we can say what is the we can give, or we can gain information about the system. Similarly, here in quantum mechanics we need to solve the equation, the equation known as Schrodinger's equation. So when we, so can you tell me what is the one dimensional form of the Schrodinger wave equation? Is not it? So if you write H is nothing but total energy operator because it gives us the total energy. So this H corresponds to kinetic energy plus potential energy. So if you put the value of the operator and then you simplify this equation, it will give you d square phi by dx square plus 2m by h cross square E minus V0 equals to 0. This is the equation in second. But in first region, this equation will become d square phi by dx square plus 2me by h cross square equal to 0. So this equation is the equation for a free particle, because in a free for a free particle the potential is 0. But here in this question we need to find out the region x greater than 0, that is the second region. So we will calculate the wave function psi. So from second, if you write it, then we can write. So in question it is given E is less than V0. So since E is less than V0, this term is negative, is not it? So if you solve, it will be d square phi by dx square minus 2m by h cross square V0 minus E into psi equals to 0. Now this is a positive quantity because V0 is greater than E. So now let this quantity we will take at phi square. So if you take this quantity as phi square, then this quantity is positive. So phi will be real because if the quantity would have been negative, then phi would have been alpha would have been imaginary. So if you put the value in terms of alpha, then it will be del square psi by del x square minus alpha square psi equals to 0. So this is nothing but d square psi minus alpha square psi equals to 0 or d square minus alpha square psi equals to 0. So what is the solution for this type of wave equation? Yes, can you tell me what is the solution for this type of differential equation? D square minus alpha square into psi equals to 0. So it will be psi x will be a e to the power alpha x plus b e to the power minus alpha x. So these are the so this is the two term of the equation. But if you see the wave function in order so since we describe the system with the help of the wave function, so there must be some parameters according to which the wave function, whether the wave function is valid or this can't be wave function, is decided. So for this, it is always said that wave function can never be infinite. So if you see here at x equals to infinite, if you put the value of x here, then a e to the power alpha x will go to infinite. So this term should be 0 so that at x equal to infinite, it is 0 because x equals to infinite, e to the power minus alpha x is 0. So the characteristic wave function is wave function at infinite is 0. So if you compare it, then it will give a equal to 0. So the remaining part of the wave function is b e to the power minus alpha x. So this is the actual wave function because this will not be infinite anywhere. Because if you see in the region, the value of x is 0 to infinite. So within this range, there is no value at which the wave function will be infinite. So this will be the correct answer. So if you see, so if the electron, if the electron with energy is incident from the left side, then the space part of the wave function for x greater than 0 will be a e to the power, sorry, it will be a e to the power minus alpha x, where b is a constant, and this constant can be again determined if you normalize the wave function. So is this clear to you?
Yes, sir.
Okay, so we'll go to our next question. The question says a free particle is moving in plus x direction with a linear momentum p. The wave function of the particle normalized in a length L is 1 by root L e to the power I p by h cross x 1 by root L e to the power I p by h cross x, 1 by root L sin p by h cross x, or 1 by root L cos p by h cross x. If you see here, it is mentioned moving in plus x direction, and the momentum is p. So what will be the wave function of the particle and normalized in a length L? So these are the four options. I'll give you some time to calculate it. Then we will discuss about the question. So please calculate. After that, we will discuss. Yes, so can you tell me what will be the free particle wave function if it is moving along plus x direction? So if you see the particle is free means I just told you in the previous question. For free particle, the potential is zero. So when the potential is zero, if you put h psi equals to e psi, then it will give you del square psi by del x square plus 2me by h cross square equals to 0. So you know the relation between momentum and energy is given by p square equals to 2me. So this equation will become del square psi by del x square plus p by h cross square into psi equals to 0. In the previous question, it was d square minus alpha square, but here it is d square plus alpha square. It is d square plus alpha square psi equals to 0. Here alpha is p by h cross. So what will be the equation? What will be the solution of this equation? It will be psi equals to a sin alpha x plus b cos alpha x is not it. So it will be a sine p by h cross x plus b cos p by h cross x. So in order to like here we calculated that for x equal to infinity, our function was infinity, so a should be 0. So similarly here we will apply the boundary condition. The boundary condition is at 0, the wave function value is 0. So if you put here sine 0 is 0, but cos 0 is non-zero. So 0 equals to a sine 0 plus b cos 0. Cos 0 is 1. So you will get b equals to 0. So this b term will be 0. So psi will be a sine p by h cross into x. So this is the wave function. Now, but here in the question it says particle, the wave function of the particle normalized in a length L. So normalized in a length L means what? Integration 0 to L psi star del psi equals to 1. This is called as the normalized equation. So if you integrate, you will find this a, the value of this constant a is 1 by root L. 1 by root L, a is 1 by root L. So the wave function will be 1 by root L sine p by h cross into x. So this is the correct option. So here option C is the correct one. In the previous question it was option A. So is this clear to you?
Yes, sir. Yes, sir.
Okay, so let's go to next question then. So the question says the wave function of a particle trapped in a space between 0 x equals to 0 to x equals to L is given by psi x a sine 2 pi by L into x. A is a constant for which values of x will the probability of finding the particle be the maximum. Options are A equals to L by 2, option B is L by 4, option C is L by 4 and 3 L by 4, and option D is L by 2 and L by 3. So here this is a trapped particle between x equal to 0 and x equal to L. And the wave function is given as this. So you need to find out the position at which the wave function will be having maximum probability. So these are the four options. Please try this question. Then we will discuss about it. Yes, did you calculate? So can you tell me what we will do in this question? How to approach this question? Okay, so what we will do? You see here the question says the wave function of a particle trapped in a space between x equals to 0 and x equals to n. So trapped in a space between x equal to 0 and x equal to L means this is x equals to 0, this is x equals to L. The particle is trapped here, that is at both these points the potential is infinite and here the potential is 0. So the particle is present here only and here Vx is 0 and the wave function is given by psi x equals to a sine 2 pi by L into x. So we know the probability of finding the particle is that proportional to the mod of wave function square. So probability that proportional to psi into psi star. That is probability that proportional to psi square. So if you see here, since psi is that proportional to sine 2 pi x by L, then P will be direct proportional to sine 2 pi x by L square. So for probability to be maximum, we want sine square 2 pi x by L to be maximum. So what is the maximum value of sine square x? Yes, can you tell me what is the maximum value of sine square x? It is 1 only. So the maximum value is 1. That means 2 pi x by L is equals to n pi by 2, where n equals to 1, 2, 3, 4, like that. Because sine 0 is 0, sine pi by 2 is 1. So sine square pi by 2 will be 1 for 2 pi x by L equals to n pi by 2. So if you calculate, x will be n pi by 2 into L divided by 2 pi. So pi gets cancelled out. It is NL by 4. So at these points, x where n equals to 1, 2, 3, like that. So at these points, the value of the wave function will be, the probability of finding the particle will be maximum. So if you see, x is n L by 4, n L by 4, where n equals to 1, 2, 3, etc. So for n equals to 1, x will be L by 4, n equals to 2, x will be, sorry, here it is not, so here we have made a mistake. So this is, if you see, n pi by, for n pi by 2, pi by 2, 2 pi by 2 is again pi. So here the values of n will only be n equals to 1, 3, 5, 7, etc. Because for 2, 4, 6, this value will be 0. So it is 1, 3, 5, 7, like that. So for n equals to 1, we have L by 4. For n equals to 3, we have 3L by 4. For n equals to 5, we have 5L by 4. For n equal to 7, we have 7L by 4. But here you see, here the question says the particle is trapped between x equal to 0 and x equal to x. So particle can't go outside this. So here if you see, this is less than x, this is again less than x, but these two are greater than x. So we will consider only these two values. So at x equal to L by 4 and 3L by 4, probability of finding particle is maximum. Is this clear to you?
Yes, sir.
Also, if you see, you can directly, without calculating all this, we can easily calculate. And how we will do that? So let me add another slide, then I will explain you. So now this is called as potential well, this type of barrier, where here it is infinity 0 to L. Now for this, the wave function, the general form of the wave function is sine n pi x by L, where n equals to not 0, because when n equals to 0, then wave function will be 0. Wave function is 0 means particle is not inside the box, but particle is always inside the box, so n can't be 0. So n will be 1, 2, 3, 4, like that. So if you see, if you compare here n pi x by L into the question, it says 2 pi x by L. So this wave function is for second level. So for first level, the wave function set is like this. So here it will be 0 and here it will be 0 because the potential is infinite. This is n equals to 1. Then similarly for n equals to 2, it will be like this. But generally what we do, we don't, because here this is 0 level and the minimum energy is not 0, it is non-zero. So we always draw the first level at some distance above the value of 0. So this is n equal to 1, this is n equal to 2. So you can clearly see here for n equal to 1, the probability of maximum is here. So between 0 to L, it is L by 2. But here the probability of this maximum at 2 points, because the amplitude of the wave function is maximum 2 points. So L, this is L by 2, this is L. So this will be L by 4 and 3L by 4. So these are the 2 points at which the wave function will be, the amplitude of the wave function is maximum, or otherwise we can say that the probability of finding the particle is maximum. So the correct answer will be L by 4 and 3L by 4. Is this clear to you?
Yes, sir.
Then can you tell me what will be the uh, so what will be the value of x for which the probability is maximum for n equal to 3? Like if the wave function is sine 3 pi x by L, or a sine 3 pi x by L, then at what point of, or at what value of x the probability of finding the particle will be maximum? Yes. So you see, like here, the curve is like this. So here it will be this. So this will be the actual curve. Then here, if you see, this is one maxima, this is one, and this is another. So here, if you this is 0, this is L by 3, it is 2L by 3. So it will be, so if you do it in six parts, so it will be L by 6, 2L by 6, 3L by 6 is L by 2 again, then 5L by 6. So at L by 6, L by 2, another one is L minus L by 6, which is 5L by 6. So at these 3 points, the wave function will be having maximum probability. Then next question, the question says a particle of mass m is confined in the particle of mass m is confined in the ground state of one dimensional potential box extending from x equal to minus 2L to plus 2L. The wave function of the particle in this state is psi x equal to psi 0 cos pi x by 4L, where psi 0 is a constant. The normalization factor of this wave function is L by 2, 1 by root 2L, 2 by root 2 by L, or 2 by root L. So we simply, what we will do? We will simply normalize the wave function because we need to find the normalization constant here. So can you tell me? So because normalization constant is this phi 0, we need to find out the value of this phi 0. So I'll give you a few minutes to try this because you can easily, we have already discussed what is the condition of normalization. So this is the normalization condition. So you can simply put this formula and calculate the integration, and you will get the value. So please calculate. So did you calculate? So did you calculate?
No, sir, I tried, but I didn't.
So actually we need to, like here, the limits were 0 to L. In the previous case, the normalization equation limit was 0 to L. Here, since x extends from minus 2L to plus 2L, so we will put minus 2L to plus 2L psi star psi dx equals to 1. Then psi star for both, since psi is real, psi and psi star both are equal. So it will be mod square minus 2L to plus 2L dx equals to 1. Then suppose psi 0 comes outside. So the psi 0 square into minus 2L to plus 2L. This is the integration sign cos square pi x by 4l dx equal to 0. What is the formula for cos square x?
One minus sin square theta.
No, no, we will not put. If you put that, then it will be again sine square. We can't take the integration of sine square, na. So we need to we know the integration of sine x and cos x. So we will write cos square x in terms of either sine x or in terms of cos x.
One
Understand?
minus sin 2, sir.
No, no. Uh, it is the. Let me write it first. So first we will do what we will do. Since this cos square x is positive for both minus 2l to 0 and 0 to 2l. So both will be having same value. So we can write directly twice of 0 to 2l cos square pi x by 4l dx equals to 1. So this is suppose cos square x integration of cos square x dx. So we will convert cos square x into what? 1 plus cos 2x by 2 because 1 plus cos 2x is 2 cos square x. 1 minus cos 2x is 2 sin square x. Is not it? So we will use this formula. So if you convert, it will be sine 0 square into 2, 0 to 2l, half of 1 plus cos 2 pi x by 4l dx. Is this clear to you?
Yes, yes.
So we will calculate. So now these two gets cancelled out. It will, so this is equals to 1. So psi 0 square into the first one is dx integration 0 to 2l, then plus cos 2x by 4 cos 2 pi x by 4l. The integration is sine pi x by 2l into 2l by pi into 2l by pi 0 and 2l. These are the integration limits. So if you calculate psi 0 square, this will be 2l minus 0, which is 2l, plus 2l by pi sine. Here it will put 2l. So if you put x equal to 12, 12, 12 will get cancelled out. It will be only sine pi. So sine pi minus sine 0 equals to 1. So sine 0 is 0. Sine pi is again 0. So phi 0 square into 2l equals to 1, or psi 0 equals to 1 by 2l root over. So this is the normalization constant. So the actual wave function will be psi x equals to 1 by 2l root over cos pi x by 4l. This is the wave function. Is this clear to you?
Yes, sir.
Okay, so we are lagging behind. We should solve fast. So the next question is, in the above question, the energy agent value of the energy agent value corresponding to this state is h cross square pi square by 32 ml square, or 2 ml square, or 8 ml square, or 4 ml square. So these are the four options. So how we will calculate the value of energy? Now, if you see, we know del square psi by del x square plus 2me by h cross square equals to 0. So we know psi. If you take derivative of twice of psi, then we will get. So this is the equation equal to zero. So if we take derivative of twice the derivative of psi, 2me by h cross square into psi equal to 0. Now we have the value of psi. Psi is 1 by 2l root over cos pi x by 4l. So if you take the derivative twice, so pi by 4l again minus pi by 4l. So del square psi by del x square will be minus pi by 4l square into psi. So if you write it, it will be minus pi by 4l square plus 2me by h cross square into psi equals to 0. That implies 2me by h cross square equals to pi square by 16 l square. Then E will be pi square h cross square divided by 32 ml square. So the correct answer will be option A. So you see in the previous question we normalize the wave function. So once we know the value of the wave function, then this from this equation we can easily calculate what will be the value of E because we know the value of psi. So if you take the derivative twice, then in first derivative it cos will be converted to sine with the uh, coefficient pi by 4l. Then if you take again derivative, then sine will be again converted to cos. But since cos is minus sine, the derivative of cos x is minus sine x, then there will be a minus sign. So minus of pi by 4l square into sine. So if you solve it, the energy will be pi square h cross square by 32 ml square. Is this clear to you?
Yes, sir.
Okay, so next question. The question says a free particle with energy E whose wave function is a plane wave of wavelength lambda enters in a region of constant potential V which is greater than 0. Now its wavelength becomes 2 lambda. Then the ratio E by V is what? The options are option A 4 by 3, option B 5 by 2, option C 3 by 3, and option D 2. So please try this question. After a few minutes, we will discuss. Did you calculate? So you see, here it is given the particle is a free particle and energy is E. So for free particle, potential is zero. So kinetic energy equal total energy, and kinetic energy and total energy relation is given by P square equals to 2m E. So this is for a free particle. Then we know the wavelength lambda is given by h by p. So h by p is 2me root over. But when it enters the region of a potential V, so now the in a region where the potential is greater than V, then what will be, so here it is 2me, but here it will be changed to E minus V because this term will again come into picture. So P prime will be 2m E minus V root over, isn't it? So here lambda is equal to h by p, equal to h by 2me. So this is initial case. Then second case, lambda 2I is h by 2me h by 2m E minus B root over. But if you compare, the wavelength becomes 2 lambda. So 2 lambda is equals to h by 2m E minus B root over. So if you solve it, then we know lambda is equal to h by 2m root over. So 2 into h by 2me root over equals to h by 2m e minus b root over. So it is, we need to find out the ratio of e by b. So if you take the square on both sides, it will be 4 into h square divided by 2me equals to h square divided by 2m e minus b. So this is 2, this 2 will cancel out to 2. This is 2h square by me equals to h square by 2me h square by 2me minus d. So 2m e minus b divided by me equal to h cross square by 2h cross square. So this h cross square cancel out. It is 1 by 2. Then gets cancelled out. So e minus b by e equals to 1 by 2. So e by e minus b by e equals to 1 by 2 into 1 by 2. This is 1 by 4. Then 1 minus b by e is equal to 1 by 4. So v by e is equals to 1 minus 1 by 4, that is 3 by 4. But in question it is given the ratio of E by V. So the ratio of E by V will be, this is 3 by 4. So E by V will be 4 by 3. Is this clear to you?
Yes, sir.
So initially when the particle was free, the relationship between energy and momentum is P square by 2m equals P square by 2m was E. But when there is potential, then this P square by 2m plus V equals to E. P square by 2m plus V equals to E. So P square by 2m equal to E minus V, and P square equal to 2m E minus V. Then P will be 2m E minus B root over. So similarly here, P prime is 2m E minus B root over. So we know lambda is equal to h by p. So for one case, p is h by 2m e, and for other case, it is h by 2m e minus b. So if you compare it and calculate, we can get the relationship between the ratio of e by b is 4 by 3. Then question number 8. The question says the radiations given by the mercury atoms returning to their normal states were studied by Frank and Hertz, and a line was observed at 2537 Armstrong. Calculate the excitation potential of mercury. The options are option A 2.36 volt, option B 1.75 volt, option C 4.89 volt, and option D 6.05 volt. So please calculate and tell me if a line was observed at 2537 Armstrong, then what will be the excitation potential of mercury? Yes, can you tell me if a line was observed at 2537 Armstrong, what will be the excitation potential? So if you remember during our discussion related to X-ray production, we had talked about a formula to directly obtain the voltage equivalent to a particular value of wavelength. So it was if what will be V in electron volt will be 1240 divided by lambda, where lambda is in nanometer. If you see here, it is in Armstrong. So if you convert this to Armstrong, it will be 12,400 divided by lambda, where lambda is in Armstrong. So it is 12,400 divided by 2537. So it will be how much? 12,400 divided by 2537. It is around 4.88. So the correct option will be 4.89 electron volt. So this is the excitation potential energy. So the excitation potential in volt will be 4.89 volt. So energy is in electron volt, but potential is in volt only. So the correct option is option C, 4.89 volt. Is this clear to you?
Yes, sir.
Basically, this question says this line was observed. So this line was due to the transition from ground state to excited state. So what will be the excitation potential? The excitation potential will be the energy equivalent to this transition or this wavelength. So the formula is 1240 by lambda, where lambda is in nanometer. But here in the question, lambda is in Armstrong. So if you convert it, it will be 12,400 divided by lambda. So it will be 4.89 volts. Then question 9. The question says find the possible terms of a one electron atom corresponding to n equals to 3. Option A are option A is 2 2s half 2d3 by 2 2p 3 by 2 1d 2d 1 by 2 and 2s 3 by 2. Option B is 2s half 2d5 by 2 2p 3 by 2 2d3 by 2 2p half. Option C 2s half 2d half 2p 3 by 2 2d half and 2s 3 by 2. And option D 2s half 2d 3 by 2 2p 5 by 2 2d 5 by 2 and 2s 3 by 2.
Sir, question page is not visible, sir.
Okay. Now is it visible?
Yes, sir, it's visible.
Okay, so there are some network issues. So please try. So here you see here the question says it is a one electron atom. So there is a single electron, but it corresponds to n equals to 3. So one electron atom and n equals to 3. So you have to consider all the possible states in which electron can be, and then we will find its corresponding spectroscopic notations.
Sir, answer B is correct, sir.
Answer B. So you have to check. So let's. Uh, so here. So how did you calculate?
Actually, S equal to 1 by 2. If it is N equal to 3 means L equal to 0, 1, 2. So when we are applying these three things in spectroscopic terms, we will get option B.
Okay. So now let's calculate. Yes. Yes. So here it is only one electron. So one electron means S is half and N equals to 3. So we know for N equal to 3, L can have 0 to N minus 1 value. So L is 0, 1 and 2. There are three values of L. So L0 S half, L1 S half, L2 S half. Then L0 S half means J equals to half. L1 S half means J equals to 3 by 2 and half. L equal to 2, H equal to half means J equals to 5 by 2 and 3 by 2. So here L equal to 0, H equal to half. H equal to half means all will be doublet terms. So it will be 2S half. From this it will be 2P 3 by 2 and 2P half, 2D 5 by 2 and 2D 3 by 2. So this will be the five terms. So here, as you have pointed out correctly, the correct option will be option B. Option B had all these five terms. So now let's try another this type of question. If there are two electrons and it is present at n equal to 3 level, then what are the terms that will come out of this out of this configuration? So what we will do first? Yes. So how we will proceed? Like previous question we did. So S is half and half. So from this half, so it will be half plus half. This is small. This is small s. Sorry. So half plus half is 1 and half minus half is 0. So now we have two values of s, but here similarly to the previous question, we have three values of L. So there will be six combinations: L0, S0, L0, S1, L1, S0, L1, S1, L2, S0, L2, S1. So in this case, J will be 0. In this case, J will be 1. Here, J will be 1. Here, for L equal to 1, H equal to 1, what will be the value of J?
What, sir?
For L equal to 1 and H equal to 1, what will be the possible values of J? So if L and S, then J is
2, sir.
the vector addition of L vector plus S vector, then what will be J? J will be L plus S to L minus S with 1 decreasing. So here you see L plus S is 1 plus 1, 2, and L minus S is 1 minus 1, 0. So it will be 0, 1, and 2. So L equal to H equal to 0, J equal to 2, L equal to 2, H equal to 1, J will be 2 plus 1 is 3, 2 minus 1 is 1, so it will be 3, 2 and 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there will be 10 terms. Here there are only 4 terms, but here will be 10 terms. So what are those terms? So if you see here, in previous question, there was only doublet terms, but here there will be both singlet and doublet. There will be more. There will be both singlet and triplet because S is 0 and S equal to 1. If you see here, it will be 1s0, is not it? Because L is 0, S equal to 0, J equal to 0. So it is 1s0. But here it will be what? 3s1 because L equal to 0, but here J equal to 1 and S equal to 1. So 2s plus 1 is 3. Similarly, here it will be P1P1, but here since it has 3 terms, it will be 3P012. Here it will be 1D2 and it will be 3D123. So this is one term, this is one, this is one, this is three, this is one, this is three. So we have total 10 terms. Is this clear to you?
Yes, sir. Okay.
Okay, so the next question. The question says the question says find the possible angles between L vector and S vector for a d electron in one electron atom. So what is the term for d electron? For the electron which is present in D and it is a single electron. So what is the term for that? Then first you will determine the term. Then after that, for this term there will be different values of L, S, and J. Then we will put that values of that values to calculate the angle between L vector and S vector. The options given are 135 and 61.9 degree, 105 and 45, 90 and 62.5, 75.8 degree, and 35.5 degree. So please calculate. Then I will discuss.
Sir, option A is correct answer. 135 degree and 61.9 degree.
Yes, absolutely correct. Option A is the correct answer. So, first, for a d electron, for a d electron in one electron atom, S is half and D means L is
Sir, 2.
2. So, J will be
5 by 2. 5 by 3.
yes. What will be the value of J?
3 by 2 and 5 by 2, sir. Both.
Yes, 3 by 2 and 5 by 2. So, it is 2 minus half and 2 plus half. So, why there are no other like here? It was 1, 2, 3. 3 terms, but here it is not 3 because if you see minus half and plus half both have difference of 1, so we have only those two values. So if you see here, for one case S equals to half L equal to 2, J equal to 3 by 2. For second case, A is equal to half, L equal to 2, J equals to 5 by 2. So now we will find out the expression for angle between L and S. So if you see, J vector is equal to L vector plus S vector. So J square is equal to L vector plus S vector dot L vector plus S vector. It will be L square plus S square plus 2 L vector dot S vector. So LS, the angle between LS is equal to J square minus L square minus S square divided by 2 LS. Because this term L dot S is LS into cos theta, and this cos theta is angle between L and S vector. So we know J equal to J into J plus 1 root over. So J square will be J into J plus 1. So cos L vector and S vector is J into J plus 1 minus L into, sorry, minus L into L plus 1 minus S into S plus 1 divided by 2 L into L plus 1 root over and S into S plus 1 root over. So if we put all the values, then in first case, it will be cos LS will be minus 1 by root 2, which is equal to cos 135 degree. Then for second case, for 5 by 2, it will be root 2 by 3, which is cos 61.9 degrees. So the values of theta are 135 degree and 61.9 degree. Is this clear to you?
Yes, sir.
Okay, so let's go to the last question. The question says,
Sir, one doubt, sir.
yes,
Sir, is it possible to solve any problem related to the particle in a box? For example, if they given number of electrons, how we can find out the lower
so
energy?
yes, we can easily solve. Do you have any question?
Yes, sir. Actually, in assignment itself, they have asked you two questions, sir. But instead of that, by changing the number of electrons, if you are solving one problem, it will be useful for me, sir.
So basically, since the assignment is the assignment date is over.
No, sir. Actually, time is there. Next week only. Any model problem related to that is sent, sir. No need to solve the same problem.
Okay, just so let me first solve this question, then we will discuss that question we are saying at last. So now this question
Okay,
says, find the value of S, L, and J for 5F5 state. So it is very easy question. So for 5F5, so 5 means you can easily say 5 means there will be this 5 is 2S plus 1 and F corresponds to L and this 5 corresponds to J. Is not it? So if 2S plus 1 is equal to 5, then S will be what? S will be 2.
two. Yes, sir.
Then F for F, L is SPDF, L is 3. So if L is equal to 3 and S equal to 2, so J will be L plus S to L minus S. So L plus S is 5, L minus S is 1. So 5, 4, 3, 2, 1. So this is the value of J. So S is 2, L is 3, J is 1, 2, 3, 4, 5. So this is the correct option. That is option C. Is this okay?
Yes, sir.
Okay, so what question have? So you see, if we discuss about particle in one dimension box, so suppose this is a one dimension potential box. One dimension means x only varies from suppose 0 to L, and here potential is infinity at both. So particle can't go outside this box. So particle will always be staying inside the box. So you see the wave function is given by 2 by root L sine n pi x by L. We just in this class we already normalize the wave function, and this is the actual wave function. And here n is 1, 2, 3, 4 like that. And energy agent value is given by n square pi square h cross square by 2m L square. You must have been knowing these things.
Yes, sir. But in reference book, they given to calculate the energy levels n square h square divided by 8 ml square, sir. Maybe instead of
Same,
that h,
same,
they have written h
exactly.
cross
Same.
2 pi.
If you convert it, if this h cross is nothing but h by 2 pi, na? So if you do that, it will be n square h cross square by 8 ml square. So you see, basically this type of question, what you are saying, this type of question generally comes for three-dimensional potential box, because for three-dimensional potential box there comes another type of complexity in terms of degeneration. So you see, simply for one dimension, if you consider, we know the 0 point energy is not zero. So this is E0, then this is E1. So E0 will be how much? E0 will be n h square by 8 ml square, is not it? So
Yes.
E0 will be n square h square by 8 ml square. So putting n equal to 1, it will be h cross square by 8 ml square. So E1 will be how much? So sorry, this is E0, this is not E0, this is E1. Then E2, E2 will be 4E0, E3, E3 will be 9E0, is not it?
Yes, sir.
Similarly, E4 will be how much?
16 is 0, sir.
16E0. So now, you see, suppose their question says, uh, now let's consider some hypothetical situation. Now I will say, suppose there is a particle with spin 3 by 2. So what will be the value of ms?
Plus or minus 3 by 2, sir.
Then will it be only plus or minus 3 by 2? It will be plus or
3
minus
by
3 by 2 and plus or minus half also.
yes, sir.
S3 by 2 means 2s plus 1 will be the multiplicity. Na? So there will be four values of ms. So plus 3 by 2, minus 3 by 2, plus half, minus half. So since ms has four values, suppose there are different energy levels. For example, if we are generally saying electron have spin quantum number half. So we can maximum fill two electrons in a level. Suppose electron has spin quantum number 3 by 2, then we can, then in that case, we could have filled four electrons in one level, is not it?
Yes, sir.
Because electrons are fermions, and for fermions, the total wave function should be antisymmetric. And according to Abbas principle also, not all four quantum numbers for a particle is same. So if you see, suppose there are different levels. This is E0, this is 4E0, this is 9E0, this is 16E0. Now I will say you there are 10 particles with spin 3 by 2. What will be the minimum energy of the system? This type of question you want to discuss now. Am I clear?
Yes, sir. Yes, sir. The same question, sir.
So basically, you see, since A is equal to 3 by 2, so in one state we can fill four particles maximum. Is not it?
Yes, sir.
So in E0, we'll be having four particles. Then the next available energy level is 4 E0. So we'll be having again 4 particles. Then the remaining particles are how much? 2, because we have 10 particles now. 4 particles in E0, 4 particles in 4 E0, and remaining 2 particles in 9 E0. So what will be the total
Yes.
energy? Total energy will be here 4 particles means each having E0 energy. So total energy in this state is 4 E0. Here each particle has energy 4 E0. So here 4 particles has energy 16 E0. Here one particle has energy 9 E0. So it will be having 18 E0. So if you add, the total energy will be 18 plus 16 plus 4. It will be how much? 18 into 16, 18 plus 16 is 34, 34 plus 4, 38. So the minimum energy 38. Is this clear to you?
Yes, sir. Yes. Now I can solve it, sir. Thank you, sir.
Okay. So, but one case, but in another thing, there if there is 3 dimension, in 3 dimension, what happens? We have nx, ny, nz, is not it? So let me add another slide. So you want to understand how we will do with the 3 dimension,
But nx, ny, nz values we have to substitute, sir.
but I know I want to tell you another important concept, and that is degeneration. So if you see, if n is 3, because minimum value of n will be 3 only, because if so not minimum, uh, minimum value of n will be 1. This is nx, ny, nz. There are three values. So if nx equal to 0, wave function is 0. So this is not possible. So minimum value will be 3. So for 3, nx will be 1, ny will be 1, nz will be 1. And the energy will be nx square plus ny square plus nz square, and that E0 term. Is not it? But if
Yes.
you see, suppose the n is 5. 5 means nx can be 2, ny can be 2, nz can be 1.
1.
But we can also write it as 2 1 2, 2 2 1, and 1 2 2. So there are three types of conditions. You understood? Because here
Yes.
you see, in previous case only one dimension, there are only one levels, because there is no degeneracy. But here there are three degeneracies. So suppose for n equal to 5, we have these three levels. So there are 10 particles. So we can have 4 here, 4 here, and 2 here. So here in this case, all these 10 particles will be having energy. Suppose this state has energy 9 E0, then all these particles will be having energy 9 E0, so total energy will be 90 E0. Understood?
Yes, sir. Yes, sir.
Okay, so we will solve it like that only. So if you are interested, I will try to solve this type of questions in the next interaction session. Hopefully, by that time, your assignment submission date will be over. So I can discuss
Yes.
the same question also again. So
Okay, sir.
I
Thank you.
again thank you for attending today's session. Okay,
Thank you, sir.
I hope this will be helping you in your future. Okay, good night.
Okay, sir. Thank you.
Okay.